Okay, so we'll go ahead and get ourselves started. Stop the screen share of the slide. So we have Lincoln Bryant from University of Chicago, who's part of the SLATE team. He's also associated with the Open Science Grid, who's going to present for us today with today's topic, enabling science collaborations with secure and flexible secure deployment as part of the SLATE effort. I'm going to reshare our call document for today and just invite folks to hop on in, help us keep notes, sign in, capture Q&A, suggest a future topic. And we are recording today's session again so that we can post this to the YouTube channel afterwards. We'll kind of ask Lincoln to kind of indicate to everybody how he'd like to handle question answers, whether he'd like to have us throw them out as he goes along, or whether he'll pause periodically and kind of ask for them. But otherwise, we will turn the time over to Lincoln and let you go.
Yeah, thanks a lot, Brian. Appreciate it, and I appreciate being invited to speak here today. As for questions, I'm happy to just take them as they come. Obviously, when I'm presenting, I won't be able to read the chat, so if there are chat questions, maybe I can answer those at the end, unless there's some extremely burning topic that needs to get answered immediately. But yeah, let me go ahead and try to set up the share here, and can everybody see that okay? Good. Okay, I see some nods. All right, I'm going to assume it's all good.
Yep, it's good.
Yeah. Okay, great. Yeah, so I'm going to talk a little bit about the SLATE project and how we're using SLATE to enable science collaborations with the power to do flexible and secure service deployment. Let's see. Let me get rid of this. There we go. Okay, so basically, we think that science at all scales, it requires collaboration between institutions, between researchers, and sharing. And when I say sharing, I mean things like sharing data, sharing resources, sharing capabilities, sharing things like access to services, sharing tools used to do analysis and simulation, sharing software. And by sharing these things, we can democratize science. And in order to share resources, across these boundaries, you have to deal with institutions that the researchers are a part of, and those institutions have policies, and those institutions have various kinds of resources and things like that. And to scale, you really have to deal with this problem, especially as you start to build larger collaborations. You start to have to deal with many institutions and deal with the policies and resources of those institutions, and somehow try to stitch those together into some usable fabric for your collaboration for other scientists. And so one pattern that's been around for, gosh, I guess it seems like decades now, is this idea of distributed high throughput computing, as kind of pioneered by the Open Science Grid and PATH, which are building, national scale cyber infrastructure that pools resources together from institutions. And that's a great pattern, and it's been really successful. But we're starting to see that users want things in addition to traditional batch workloads that they've been using for quite some time now. At least in our space, in the higher energy physics space, we're seeing that users want to have things like facilities to do sort of this low latency interactive analysis, right? They want all of the power of this vast distributed resource, but then they want it sort of brought forward to them in a way that maybe like a Jupyter notebook, right? And so I think we need to think a little bit about how we're going to innovate in the space of cyber infrastructure to provide those kind of resources to users. And so if you're a collaboration today and you want to go out and build some distributed computing platform that goes across many institutions, It's not easy today. There's, to start with, there's the people problem, right? You have to sort of figure out all of the people who are in the dependency chain to be able to do something as simple as, run a service that communicates across 2 sites, right? You have to cross various institutional boundaries in terms of, the policy, in terms of administrative domains, things like that. And then even if you can solve the people problem, there's a lot of diverse technology stacks that people choose to implement their research facilities with, right? And so, if you can manage to get over all of these humps and put together some kind of distributed platform, you still have to maintain the thing, right? And so once if you're going out to build a data lake and you're going to involve 4 institutions in it, right? You're going to have to get through actually setting the thing up. And then once it's running, you're going to have to maintain it, right? You're going to have to make it accessible to users. You're going to have to figure out how you coordinate your updates across sites. If you have sites that are slower to update than others, you have to think about maintaining that compatibility across a large range of software versions. Once things sort of reach a steady state, it becomes difficult to introduce new services and new software. Even if you can manage all of those things, you still at the end of the day have to do monitoring and alerting for all these distributed platforms, right? By moving the problems or moving the services across a distributed fabric, you have more points of failure now, right? You have to keep track of those things. And you can imagine there's lots of different implementations of things that would be a distributed computing platform like this. Caching networks, content delivery, science gateways, that sort of thing. So we thought for quite a while about how we could address these challenges, right? Because we have experience running distributed computing facilities in the OSG space and in our LHC computing space, and we wanted to know how we would try to tackle this for the future, right? When we want to build some new distributed thing, or one of our colleagues does, or just somebody out there in the community wants to build some kind of distributed platform, what do we do? And so the first thing we thought, is we have this tool and this pattern called the Science DMZ. And that's a really effective and excellent tool that we have in our toolbox to help with making research possible across institutional boundaries. And we thought we would take the Science DMZ, right, and then we would augment it. And what we would do is extend the DMZ to include this open and secure platform for running long-lived services, right? So just as today, you can imagine if you use something like the OSG, right, they have the ability to stitch together computing resources. They can send you batch jobs that then go to your HPC and do some work. We want to try to take that idea further and be able to send entire services that live at sites, and try to figure out how to do that in a secure way that would actually get past a CISO's office, or actually fit within the operational model of these facilities. So one of the immediate things that we wanted to resolve then was that, obviously we can't give people a wild west of applications, right? We can't let anybody run any application on any site, right? That would be a disaster. But instead, what we could do is take an app store-like approach and build a catalog of applications that would be trusted by resource providers. And we want to give those providers really fine-grained control over who can run things at their site and what specific applications can they run. And then that catalog itself would be, sort of maintained and scrutinized by the team running this platform. And then once we're able to, build out all of the primitives for allowing people to give people sort of the mechanism to send services to facilities and run services places, it made sense to us that we should try to build teams of application experts, right, to try to focus effort in running a particular service, and put it in the hands of the experts who build the service and let them operate it at the sites. So as a system administrator, you don't have to worry about, the particular, YAML configuration file for some service that somebody dropped in your lap. You instead worry about, keeping the platform itself available such that people can use it. And then, of course, we're very cognizant of security challenges and things like that. And so, we want to make sure that all of this happens in a very secure way. And so these concepts kind of coalesced into this model that we call federated operations. And when we were coming up with this idea, we worked very closely, and we reached out to the trusted CI folks and worked very closely with them, because they're really the experts in doing things in a secure way and building these policies and all of this stuff and establishing this trust framework for what federated operations might look like. And then after we worked with Trusted CI, we went and worked with our colleagues at CERN and the Worldwide LHC Computing Grid to kind of try to develop this further and make it fit for our particular use cases. And so once we had sort of the core principles in mind, we went and built this project called SLATE, which implements, it's an implementation of this federated operations model. And so this was an NSF DIBS award, which we've been working on for a few years now. And I'm going to go into some of the details about SLATE itself. So in a nutshell, SLATE stands for Services Layer at the Edge. And the idea is, I guess kind of the elevator pitch, is that it's a platform for programmatically developing applications and deploying applications to sites in a secure and easy to use way. The three pieces that are sort of fundamental to this, our three pillars, are that we have a centralized service that uses federated identity to manage users, groups, and clusters, and sort of the relationships between them. So you can imagine users get organized into groups, groups get allowed to run applications on clusters, that sort of thing. We have a REST API that fully implements our platform, which is used by our web portal and also a command line client. And finally, the most important piece is we have this curated catalog of applications, right? This is sort of the SLATE app store. And we've very intentionally designed these in such a way that that folks who may find SLATE interesting but not for them could still go to our catalog of applications and take those things off the shelf and still use them with their site, with their resources, without necessarily having to use all of SLATE. So the architecture, we have chosen to use Kubernetes sort of as a basis for this platform. There, at the time, and still is, a lot of momentum in industry for this platform. But we wanted to try, again, to be very conscious of security at sites. Kubernetes sort of out of the box is not quite suited, I think, to a lot of our use cases. It's a little bit tricky to do things like multi-tenancy right now. The permissions and things like that can be challenging for people to set up. And so what we wanted to do basically was to build Kubernetes clusters that could live at sites. And instead of, for example, just giving everybody a Kubernetes machine and trying to build some large federated thing or some large stretched cluster, instead what we want to do is have sites build a Kubernetes cluster. It could be as small as a single node cluster. And they have ownership of it. And then we sort of slide in along the side as a user, hopefully a good user, of that Kubernetes cluster. And then we have sort of our own abstraction, which federates everything together. So end users of the system can interact with this API, and they can request to install applications to various Kubernetes clusters. As I mentioned, it uses institutional identity, so it uses CI login by way of Globus. So you can log into this portal with your institutional identity, you automatically get an account created, and you can't do anything out of the box, but you can request to join groups, and those groups can deploy applications to clusters and things like that. The permissions model is very Unix-like. We simply have users and groups. Users get organized into groups, and groups get allowed to do things on clusters. And it's actually kind of interesting because the catalog turns out is a nice point of separation for users and developers. End users of the SLATE catalog don't really think a lot about Kubernetes details. So we don't have users, if you're familiar with Kubernetes at all, we don't have users really thinking a lot about deployments and services and replication sets and all these these objects that have a really high learning curve to try to grapple. Users think more about the particulars of the application that they're installing, right? So if they're installing a Globus door, right, they're going to look and say, okay, this is the file system that I want to make accessible to Globus, and I want to use CI logon as my identity provider and that sort of thing. While on the back end, we're sort of translating all of that into Kubernetes YAMLs and deploying those onto clusters. So here's some examples of successful uses of federated operations. So one of the things that we're actively supporting is this content delivery network for the Atlas collaboration. So Atlas is using SLATE to deploy caches in this data delivery network using this software called Xcache. Xcache is sort of a special variant of this software xrootd that's developed by Stanford. And we kind of have this nesting doll approach to assembling these applications. So essentially Stanford delivers the xroot or Xcache application that has been packaged into containers by the software team at the Open Science Grid, who's supporting a lot of the science for the LHC and other open science type of projects. They package it into containers. And then the SLATE team takes those containers and we package those into Kubernetes manifests, Kubernetes objects, and templates, which are called Helm charts. And so we package everything up and put a bow on it. And then one person from the Atlas collaboration is able to launch these Xcaches on various institutions that have SLATE machines and run them, right? And so it's really nice because if he wants to do an update, he can update all of the caches at once, right? And he can, monitor them centrally and all this other good stuff. So this is kind of what an Xcache deployment looks like. I had mentioned a couple times now that we have these YAML files that have a description of the service. So kind of on the right here, you can see that he's got a lot of stuff plugged into this, like he wants to collect metrics out of this service and he wants to send them to this host. And this particular cache is for UChicago. And he wants to write all of his cache data to these various directories that have been exposed into the container. It has all these other software specific configuration options like watermarks and how much memory it should use for caching and things like that. But really nothing in this configuration file is Kubernetes specific, right? This is really application details. And then on the left, once he's satisfied with that configuration, he can go and he can create a secret and upload it into SLATE, which contains like an X509 certificate, and that gets encrypted at rest in SLATE. And then if he wants to deploy that to a cluster, he can put that secret onto the cluster, and then he can install this Xcache application very simply with this sort of single line where he says SLATE app install Xcache. He gives it a group value. He gives it a cluster where he wants to install it, and he gives it this configuration YAML. And then once he does that, SLATE sort of takes over and builds all the Kubernetes objects, and it pulls the containers down and starts running this application. And then if he wants to, update it down the road and he has a new version of his container, he can do something as simple as SLATE instance restart. SLATE will shut down the old container and bring up the new one with the latest version of the software. There's a lot of other interesting stuff, like you can get metrics out of it. You can use SLATE commands to read logs and that sort of thing. Another use of SLATE is at TAC. The Alice experiment has some large allocation where we want to do some of our workloads on Frontera, which is a very nice supercomputer and is well designed for the kind of work that we want to do. And so instead of trying to pull all of our software there and have them run it for us, so we can have our job gateway, so we can have our upstream system, that's running in Switzerland somewhere, send jobs to Frontera, or even instead of us trying to run something in a Scream session or a cron job, which at a lot of HPC sites isn't even allowed. What we instead did was we sent a piece of hardware down to TAC, and they were very enthusiastic about helping us with this, and they were willing to install this hardware for us and set up the SLATE software on it. And we're able to now deploy applications to TAC that sit sort of in the same network as Frontera and are adjacent to that machine. And we can run all sorts of workloads that way. And the really cool part about it is that this isn't exclusive to Atlas, right? This isn't Atlas's SLATE machine or anything like that. If other collaborations came along and they said, oh, we have a science gateway that we really want to run and have it sit next to Frontera and have it use our allocation on that machine, that's something that is possible with the SLATE platform. You could come in and say, I have the service, you could package up that service, hand it to the SLATE team. If we put it in our catalog, you could make that available on the Frontera machine after you, negotiate with their admin staff there to get you approved to deploy applications. And so that's kind of neat how you can, have multiple collaborations sort of packing all these services on this machine and have it, adjacent to a supercomputer. One other example is for deploying hosted compute elements for the Open Science Grid. So this is the OSG's, I guess they call it job gateway. What the hosted CE does is allow you to have a long-lived service that sits either at a site or can communicate with a site over the wide area network via SSH. And it will submit OSG workloads called pilots. It'll send pilots to your HPC and then have those connect back to the Open Science Grid sort of open science pool. And then real user workloads will come in and then run on all those resources. And so to host this this job gateway, what we're doing with SLATE is, the OSG has adopted SLATE as their deployment platform for these hosted compute elements. And so they have containers that they run for lots of institutions. You may even see your institution here. And they run them at UChicago, and they run them at UW-Madison, and some sites who have particular security requirements, like they don't want to allow inbound SSH over the wide area network. They run a SLATE cluster, and they run their own hosted CE on that machine within their network. And so then the only traffic that can come into their HPC is this sort of token secured or X509 secured Condor traffic, right? Instead of opening an SSH, in the firewall, which can be difficult for some sites. And so SLATE is designed to be open and allow collaboration, from many collaborations who want to build these distributed scientific computing platforms, right? And so what we want to do is use SLATE to enable that kind of work, right? We want to have SLATE, running it for NSF large facilities, right? We want to have, new services to be able to be spun up very quickly, right? And as a developer, right, you can quickly iterate on a new service and sort of blast it out there onto many different sites who are willing to run your application, and sort of quickly bootstrap your multi-institutional, scientific software. And then for sites, the benefit is that you only have to trust certain entities, right? You have to trust that the SLATE project is doing a good job of scrutinizing applications, and you have to trust the operators who want to deploy things onto your site, but you don't have to think a lot about the details of the application that you're going to run on your site. You'll know kind of sort of the high level details, like, oh, it's going to accept traffic on this TCP port, it's going to send things on this other TCP port, and it's going to run and do some some sciencey thing that we approve of, and you don't have to get down into the trenches of figuring out the exact configurations and maintaining and optimizing all that stuff. We kind of push that to the experts who are writing the applications and let them be responsible for that. So the next thing I wanted to get into was kind of how how a SLATE application looks under the hood. Basically, a SLATE application is a Docker container and has a Docker file that describes how the software is installed. That is plugged into a templated YAML file that describes your application in terms of Kubernetes objects. So if you're familiar with Kubernetes, these are things like pods and deployments, ingresses, services, and so on. And then we templatize that with a piece of software called Helm, and then make that templated YAML file visible and usable for operators of the service, right? And so they don't have to think a lot about Kubernetes. They mostly think about the application details. And then, if somebody were to build a new SLATE application, they would send it to the SLATE team, send a pull request on our catalog, which is just hosted on GitHub. And then, we can pour over the application and scrutinize it and give it our stamp of approval if it looks good to us. The catalog itself is designed to try to, ensure the quality and integrity of Docker containers. We have, these security policies that we developed with Trusted CI as a way to do this curation process. And, I wouldn't go so far as to say that, any container in SLATE is going to be 100% secure for all time, always. But we do try to do a diligent job of making sure that the applications in our catalog are not malicious, that they're not going to break your site, even in non-security contexts. Like we want to make sure that, when you run a SLATE application, it doesn't accidentally, denial of service or other stuff, things like that. And so the containers that we're pulling into SLATE are from sort of these trusted repositories, right? Aside from the SLATE team itself building containers, we want to trust other teams in our community, right? We want to trust folks like the Open Science Grid or CERN or the Condor team or the Perf Sonar team, things like that. We think that those are all fairly, safe entities. And so, yeah, we source containers from there, we curate them in the catalog here, and then those get pushed out on the clusters. Here's a screenshot of the current stable catalog of applications. There's many more applications in what we call the unstable catalog, but those things haven't been tested well, and so we don't necessarily give those our complete stamp of approval. But here are the stable applications. We have things like Globus Connect is a very useful and popular thing. We have some database type of applications. We have Grid FTP. We have the OSG compute element, which is really handy. For example, if you're one of these sites that has a CC Star award and you want to contribute your resources back to a national effort like the OSG. We have other caching applications like Frontier Squid, and I think Xcache is on here somewhere. And so it's that kind of thing. As I had mentioned way back in the beginning of the talk, all SLATE applications are just vanilla Helm applications, and Helm is a popular tool for packaging up Kubernetes software. And so, if you look at this and you're listening to this talk and you're thinking, I don't know about this federated operations thing, I don't think that's for me, but I would like to have a containerized Globus. You can do something like, use the Helm software and just add the SLATE repository to your Helm setup. Right, and so we've tried to make sure that all of the components of SLATE can sort of be modular in the sense that folks could pull that off the shelf and do something with it. So in fact, we had a collaboration with our friends in the CMS experiment at Fermilab, and they wanted this the service that we put together. Well, we didn't build the service, we packaged the service, this file transfer service, FTS. And they basically just took our container off the shelf, and then they were able to use that in sort of a different mode than the SLATE, federated operations mode. And that's something that we want to actively support. In fact, I think that, as a community, we have an opportunity to build, sort of a catalog of applications that are appropriate for, the research community. Right? I think that's something that we could come together as a community and build. And in fact, one thing that we may want to very seriously consider is building, a container registry. Maybe it lives in the network. Maybe it lives on the Science DMZ. Because as folks start to ramp up their usage of this, we're going to be doing a lot of container pulls over the wide area network. Even outside the SLATE context, just folks who want to containerize their software to run it at your site. And so maybe it makes sense for us as a community to build a registry that has all of these scientific applications in it, where we can do some vulnerability scanning, or we can make sure that things get patched. Because if you're familiar with Docker Hub at all, Docker Hub doesn't necessarily do those things, right? It just accepts a tag that says latest, and it doesn't make any, doesn't push any requirement onto the people who maintain it to patch the thing. And so if your users are running random applications from Docker Hub, those may not necessarily be up to date with all of the patches. Yeah, and so in general, Docker in particular is starting to clamp down a little bit, right, as they try to monetize and try to do their sustainability type of stuff. And so yeah, we have an opportunity, I think, to build a container registry for our community. And so if you want to add your application to SLATE, I kind of went over this before, but basically you would build your Docker file and a Kubernetes description of the application along with the Helm chart, and then you would submit that to the SLATE incubator catalog for inclusion, and then somebody on the SLATE team will review that application, and if it all looks good, we'll merge it in and we can start trying it out. I have to note though that this is pretty strictly restricted to open source, or at least freely distributable software, right? We can't just due to the nature of licensing and stuff, we can't have MATLAB applications or things like that, right, that we would run for folks. So that's definitely one drawback. But once your application's approved, it'll be available to all users and all sites that approve your application. So you can use this to sort of rapidly spin up new services sort of across the entire US computing fabric. So here's some more details about how an application sort of looks from a user perspective, and also from sort of the SLATE developer perspective. So if a user wants to deploy a new Globus store, they can grab the Globus config file, and it looks something like this out of the box. Or it doesn't expose every possible option for Globus, but it exposes enough of them to be useful. And so you can set things like incoming port range, or what path you want things to run on, and what the endpoint should be called, and how they should log into this endpoint. And then that gets mapped over here into this Kubernetes YAML. And then that's the thing that's actually assembled into a Kubernetes object and put on the SLATE cluster at the site. And so if you wanted to deploy a Globus door, you could basically have a simple Globus store running in something like less than 10 minutes once you ask SLATE to install it. So you do something as simple as you get the configuration file, you create some secrets with some Globus information, so SLATE can configure that endpoint in Globus. You give it the configuration file and where you want to run it, and it basically goes through this really simple timeline of SLATE creates all these objects on the cluster, it downloads the container, all the Kubernetes objects sort of settle and get instantiated because it's all asynchronous. And then your pod starts up, and users can activate that door via CI logon, right? And so then if there's a new version of Globus that comes out, it's on 4.20 and 4.21 comes out, you can do something as simple as a SLATE instance restart, and it will keep all the configuration in place, but go and download the latest and greatest container and put that on your SLATE node. SLATE also has, via the web portal, some useful metrics and information and stuff. If you install our Prometheus plugin, it will start gathering metrics for all of the containers running on your cluster, and it will forward those back to SLATE so you can see them in the web portal. So like here is a picture of one of the instances that's running for Globus. This is a Globus store that I'm running at UChicago to facilitate data transfer from TAC back to UChicago. So that's running here, and then you can see like this network utilization, right? And it happens on a per container basis. So that's kind of cool. If you just want to goof around with the SLATE CLI and try to get a feel for the software and try to get your hands on it without any commitment of building a SLATE Kubernetes cluster or anything like that, we have this tutorial environment called the SLATE Sandbox. So you can go there and log in with your federated identity. It'll give you a little shell, and you can run through these instructions it has here, and you'll get to deploy a simple web server, like a hello world with Nginx, and you can see that running. We have a lot of clusters that recently joined SLATE. This is all within the last year or so. A lot of these probably look kind of familiar. I'm not going to go through the whole list, but I did want to mention one of the interesting ones is we managed to deploy a SLATE cluster at the South Pole on behalf of the South Pole Telescope collaboration, which I do believe takes the crown as the southernmost Kubernetes cluster in the world. So that's kind of neat. If you want to join SLATE, you can either bring your own Kubernetes cluster that you have today, or you can visit our documentation, and we have a guide on how to stand up your very own single node Kubernetes cluster. We've tested SLATE with a variety of implementations of Kubernetes. That world is still very fast moving and molten right now, but we've tested things with kubeadm and kubespray and K3s, and those all basically seem to work okay. Another interesting thing that we've done is tested SLATE and are running in production at TAC using SLATE with the Singularity CRI. So the Singularity CRI replaces Docker entirely as its execution engine and replaces it with a Singularity-based execution engine. And so this was very important for sites like TAC because they don't support Docker at all. But happy to report that that's running, and we've seen some success there. We recently developed this very simple perf sonar testnet. So you can set up your SLATE cluster and immediately start doing something useful with it by putting perf sonar on that cluster, and you can use the perf sonar toolkit to measure latency and throughput and all that stuff against other clusters in the SLATE Federation. Yeah, and finally, I just want to say we're really happy to provide these tutorials if you or your institution or your collaboration is interested in this software. We'd be happy to provide a tutorial for your group or even one-on-one type of sessions. And yeah, so in summary, we've been building this federated operations model. SLATE is an implementation of that model. We believe very strongly in this model, and the SLATE community is growing, and we've added several new sites. And so far, our use cases have primarily been things like caching networks, using SLATE to deploy things like Globus or OSG compute entry points. With I'm sure many more applications coming down the pipe. And in general, we find that users are there's growing interest in things like Jupyter on SLATE. There's growing interest in things like tools like Open On Demand is another thing that we've been working on very heavily. Like, how can we provide these sort of services to a site through SLATE? How can we provide things like Condor If somebody wants to build a large Kubernetes cluster, can they use SLATE as a mechanism to deploy a pool of Condor workers there? We have a very strong relationship with our friends in the Open Science Grid and Path, the software team there, who has, I keep meaning to fix a slide, contributed many contributions. They've contributed lots of things to the catalog. They've done feature requests and patches and bug fixes and things like that. And so we're really grateful for that, for their help there. But in general, we want to closely collaborate with others. We'd like to extend our reach, and we'd like to help you if you have some applications that you want to run in a Kubernetes fashion, or you have faculty at your institution that are collaborating in these multi-institution science organizations. And broadly, I would ask, what is it that you would like to see containerized in this way? Does this technology make sense for your site? And so I think this is finally just some information on how to get in touch with us. You can visit the SLATE homepage. We have a Slack bot that will invite you to our Slack. You can send us an email, and just want to note that we have we're very open to collaboration. We have a open working call that happens on Wednesdays at 3 p.m. Central. So you can just ask us for details if you'd like to just join and get a feel for what's going on in SLATE, or ask questions, or anything like that. So I think that's the end of my presentation, and thank you very much. Be happy to take any questions.
Feel free to unmute and throw out any questions you'd like, or type them in chat.
Hi, this is Chuck Atkins from Kitware. I just want to kind of clarify and make sure I get my understanding correctly from what it seems the SLATE stack is to kind of give you a way to do the multi-institution deployment of kind of services and applications that maybe run alongside the HPC resources, but not something that would run on the HPC resources, right?
Yeah, exactly. I mean, it seems feasible that there could be things that you would want to run on the HPC as deployed through SLATE, but I don't think the technology's there yet. We certainly don't want to replace anybody's HPC.
Sure.
We want to build, essentially little sidecars that live along the HPC and expand the functionality of it.
Yeah. Okay. Because I'm almost thinking because there's certainly a kind of types of where you'd have maybe applications that you would want to have broadly available that would want to run on the resources, but that you would want deployed in a kind of multi-institutional accessible way. But I guess I could almost envision having a service that would run within SLATE that would kind of, it could access those resources, just like submit jobs to it and kind of be a gateway to,
exactly.
If you will, instead of, okay.
Yeah, that's exactly the kind of use case we want to support. And I think these things are actually going to get really interesting in the next few years, because folks are working on ways to make the Kubernetes worker executables run without root. And if they could run without root, then that means that you could run them on your HPC as a job and do something like a pilot system where you might have your command and control stuff living on SLATE, but then they submit, users can submit work via the gateway that uses their allocation, runs those pilots on your HPC, and then accepts work from that command and control interface. And you could also distribute that across institutions.
Yeah, I'm kind of thinking directly of the use case of something like ParaView, where you would want, an end user might have like the ParaView client on their desktop, and then could access kind of a gateway sitting on SLATE that could submit a job to the cluster that would, grab, 50 nodes, 100 nodes or whatever to run the PV server on, and that kind of tunnels through the gateway hosted on SLATE, something like that.
Yeah, I think that would be a really cool use case.
All right, thank you.
Yeah.
There's a couple of questions that have been dropped into chat.
Okay.
So do you have chat up, or you want me to read
them? Yeah, I can read the questions from chat if you like.
Okay.
Okay. So it was asked by Clifford, have you seen any usage requiring special compliance frameworks, i.e. HIPAA, is that possible? We haven't seen anything with HIPAA. It, I think, would be challenging. I don't think it would necessarily be impossible, but you know, we would have to have a driving use case to do some kind of you know, HIPAA compliant software installation. But I don't think it's impossible. I hope that answers your question. Okay, so from Amy, recently began using Cyverse. Would you say that it's more data project focused and this is more enterprise service? I mean, I don't have a lot of experience with Cyverse, so I can't speak to that too terribly much. But I would say that SLATE is certainly not focused on, you know, just enterprise applications. You know, we're very interested in you know, running software for scientific collaborations. And, you know, it could be the case, for example, if we were, you know, just spitballing here to work with the Cyverse people, we could potentially use SLATE as a platform to deploy their software at other institutions. That might be, you know, kind of a use case for SLATE. We kind of see it as sort of this foundational, you know, software and approach, so people can build things like, you know, like Cyverses and things like that, and stand them up at other institutions quickly. And you also asked, related to the previous question, could someone use this to plug into other HPC rather than having their own institutional HPC? Yes, I mean, I think this is, it would all depend on where the SLATE node lives. But, you know, this certainly has been used to enable OSG, right, to launch these job gateways. So you could, you know, for example, at the University of Utah, right, I think we have our job gateway running in SLATE, and that's able to use the Utah, you know, CHPC systems to provide work for users that are in SLATE, or that are in OSG. With regards to Exceed specifically, yeah, I'm not exactly sure. Okay, so from David, does the platform support running Kubernetes jobs? There's nothing that excludes it. You know, a lot of SLATE clusters are sort of on the small side. So if you want to run jobs in the sense of having a, you know, scientific workload of some sort that may be doing some heavy data crunching in some way or doing some simulation, that's probably not going to get a lot of traction on a SLATE cluster, just because most of them are so small and are mostly meant to augment sort of existing HPCs. That said, if you were using the Kubernetes job interface to do something like run small ephemeral tasks that might support, you know, a larger framework or a larger piece of software, you could certainly do that. All of the Kubernetes primitives are available to SLATE for the most part. Any other questions?
We're coming up on about the end of our time. If there's any last few questions, let's see if we can get them out so Lincoln has a chance to answer them. If not, we'd really appreciate the time and effort you put into putting this together for us, Lincoln. This was very interesting.
Yeah,
a good presentation.
Thank you for the opportunity to speak, and thanks everyone for listening.
So I saw that Lincoln did put in the top of our call document a link to his slides, as well as some of the links that he shared there on that last slide page. So again, whether or not you go back to the slides or to the links there just in the call document, that contact information is there. We will post the YouTube recording as soon as we have that up onto the various usual locations, as well as putting the link to it right inside the call document itself. But if there are no other questions, we will thank everybody for attending today. And thank you again, Lincoln, for the presentation. And we'll see everybody next time. Thanks, everybody.
Thank you.